is called function overloading. The function with the same name must differ in one of the following way. Function overloading using different, it has normally two types: function overloading using different parameter types, function overloading using different number of parameters. So the function with same name must differ in one of the following ways: number of parameters, type of parameters, and sometimes the sequence of parameters. Function overloading allows the programmer to assign same name to all functions with similar tasks. It helps the user in using different functions easily. The user does not need to remember many names for similar type of tasks. In C++, two functions can have the same name if the number and or type of argument passed to it is different. These functions have the same name but different arguments are known as overloaded functions. For example, we have four functions: in test with no argument, in test with one argument, float test with one argument double, and in test with two arguments. One is int a, second one is double b. So here we clearly see that we have four functions with same name test, but these functions are differ from each other uh, with different arguments passed to it. Notice that the return type of all these four functions are not the same. First two one is int, third one is float, and last one is again int. Overloaded functions may or may not have different return types, but they must have different arguments. For example, int test int a and double test int b. So here both functions have the same name, the same type, and the same number of arguments. Hence the compiler will throw an error when we want to compile it. Let's have an example for function overloading. Is example: after declaring our header files, we declare a function float with name absolute, and we pass it a parameter type float. So this is a function with float type parameter. In the body of this function, we set a test: if var less than 0.0, then var is equal to minus var, and also we want to return a value var back to the main program. Then we close this function and we declare another function with the same name but with different return type. This time we use keyword int absolute, and our parameter is int var. So in the body of this function we write if var less than 0, then var is equal to minus var, return var. In the main program, first of all we call function with int type parameter. So we write cout absolute value of -5 is equal to, and we call absolute -5 and then NL. Then we call function with float type parameter and we write cout absolute value of 5.5 then we call for function absolute 5.5f and then handle. The output of this program is look like as the absolute value of minus 5 is equal to 5 and the absolute value of 5.5 is equal to 5.5. So here is the explanation of the previous program. In the main program, when we when we call function with absolute minus 5, the control goes to the int absolute int var function. And when we call absolute 5.5 with float type parameter, the compiler check the uh, argument type and then it calls the function float absolute float var. So in this program we overload the absolute function based on the type of parameter passed during the function call. The corresponding function is called. So function overloading with different number of parameters in this example. Uh, First we declare a function with two parameters. We write void display int var1 comma double var2. Here we have two parameters, one is int and second is double. And in the body of this function we write cout integer number and cout double number. We want to display var1 and var2 variables on the screen. Then we close the body of the function and we declare another function with the same name, with the same data type, and but this time the parameter is only one, and that one parameter is double var. So in the body of this function we want to display the value of var and then we close our function. Then we declare another function with single variable but with different parameter data type, and this time we declare it as void display and into the parameter we used int var. So function with int type single parameter is declared here, and into the body of the function we write cout integer number and we want to display the value of our parameter var. The main program we start with int main and into the body of our program we display two variables, int a is equal to 5, double b is equal to 5.5. These two parameters are our local parameters because these two parameters are only usable in the main program. Then we call the functions display a and display b, and similarly our third function. If we when this program runs, the output is look like as integer number is equal to 5 display, float number is equal to 5.5, integer number 5 and double number is equal to 5.5. What happened to this program that when we call it first time display a, it checks the data type and goes to the function y display int var and it displays its value var. When we use function with uh, double type variable b and we call function display and we pass it a double variable b, then it checks its parameter argument and goes to the function with double parameter. Yeah. And if we call the function with two arguments a and b, where a is an integer type and b is an double type, the compiler check the argument types, argument numbers, and automatically it goes to the first function, which one is void display int var1 double var2. So here the display function is called 3 times with different arguments. Depending on the number and type of arguments passes, the corresponding display function is called. C++ recursion, a function that calls itself, is known as a recursive function, and this technique is known as recursion. In this diagram, we clearly see that we have a function with the name funct with no arguments and with no return type, and into the body of this function we call it function and we write funct and a parenthesis. In the main program we call this function funct and with parenthesis. When this program runs, compiler check the int main program where we call this function, and control goes to the void function, and into the body of the function it again see that we want to call this function by itself. So this type of functions called recursive functions. Recursion leads to several number of iterative calls to the same function. However, it is important to have a base case to terminate the recursion. Recursion is an efficient approach to solve a complex mathematical computation task by dividing it into subtasks. In programming, it allows programmers to divide a complex problem into subtasks and to solve them individually to reach final solution. So any problem that can be solved recursively can also be solved iteratively, but recursion is considered as more efficient method of programming as it requires the least amount of code to perform the same complex task. Although recursion is not recommended for all problems, but it is best suited for some problems like sorting, searching, in order, pre-order, post-order, tree traversals, DFS, or graph algorithms. However, recursion must be implemented carefully, otherwise it may lead to an infinite loop if no base condition is met that will terminate the function. So be careful before using recursion in your programming. Working of recursion in C++, uh, in this diagram we see that we have a function with name recurse with 0 argument and 0 return type, and in the body of this function we call this function itself, and in the main program we call this recursive function, and when compiler reads the this in the main program recursive call, then control goes to the recursive function, and in the body of recursive function it finds again the same function call, so it goes back to the start of the recursive program. The cursive continues until some condition is met. To prevent infinite recursion, if-else statement or similar approach can be used where one branch makes the recursive call and the other does not. Before seeing the example, we see the type of recursives. Type of recursion. Recursive function can be following two types based on the way it called. Number one, direct recursion. Number two, indirect recursion. Direct recursion, when a function calls itself directly, it calls as direct recursive function, and this type of recursion is said to be direct recursion. So in this diagram we clearly see that we declare a function void recursive, and in the body of this function we call this function by itself. Indirect recursion, when a function calls itself indirectly from other function, then this function is called as indirect recursive, and this type of recursion is said to be indirect recursion. For example, we have a function, we name it fun1, and in this function we call another function recursive, and we have a second function with the name of recurse, and in this function we call a function fun1. So in the main program, when control goes to one of these programs and compiler sees that these two programs call themselves from their bodies. Here is the example of a recursive program. In this example, we want to find the factorial of a number. The factorial of a number is equal to, for example, n is equal to 1 multiplied by 2 multiplied by 3 multiply so on up to that number. We see the same such an example if and we do the same factorial and find the same factorial of number by using loops in our previous lectures. So in this example we find the factorial of a number, and this time we use recursive function. Let's start the programming. First of all, we declare a function uh, and name it factorial, and we pass it a parameter int. Then in the main program we need two variables, and we declare two variables, that is int n and result. And after declaring the two variables, we ask user to enter the number whom we want to find the factorial, and then we use other variable result to display, and also we uh, use this variable to call the our factorial function. So we call factorial and pass it the number that from n, and then we display our result on the screen. So when compiler reads the line result is equal to factorial n, control goes to the factorial function, and we define factorial function as int factorial and into the argument int n. In the body of this function we write if n is greater than 1, then it returns n multiplied by factorial n minus 1. Otherwise, if n is equal to 0 or less than 0, then it returns only 1. For example, user write a number 4 as an input, then this function calculates the factorial of 4 is equal to 24, which the calculation of factorial of a number is a simple example of recursive technique. Suppose the factorial of 4 is to be calculated. The recursive solution of this problem can be shown as follows. In the main program, we call the result is equal to factorial n, then control goes to the factorial function which one is int factorial int n, and n is equal to 4, and in the body of this we write if n greater than 1 return n multiplied by factorial n minus 1. We again call this function by itself, and this times it calls again itself and control goes to itself, so it becomes uh, but before calling itself it decreases value 4 to 3. So int factorial int n, if n is equal to greater than 1 return n multiplied by factorial n minus 1. Now when we write n minus 1, n becomes 2, and as factorial n minus 1 it calls itself, then again it calls itself int factorial int n in the body. If n is equal to greater than 1 return n multiplied by factorial n minus 1. So again it calls itself factorial n minus 1 gives us n is equal to 1, so when it calls itself it is int factorial int n, and in the body if n is equal to greater than 1, now n is equal to not greater than 1 return n multiplied by factorial n minus 1 not compiled, so control goes to the else statement, so it returns us well, it return 1 to the previous value. So this figure shows that factorial can be calculated by decomposing the problem. The factorial of 4 can be calculated by multiplying 4 with the factorial of 3. The factorial of 3 can be calculated by multiply by 3 with the factorial of 2, and so on. So when it first calls itself, we have a value 4 multiplied by factorial 3. When it calls second times, n is equal to 3, and so it 4 multiplied by factorial 3 multiplied by factorial 2, and then the third time it calls 2 multiplied by factorial into 1, and then the last time 1 multiplied by factorial into 0. So the last one gives us the result 1, second time 2, third one 6, fourth one 24. So as we see, the factorial function is called itself. However, during each call we have decreased the value of n by 1. When n is less than 1, the factorial function ultimately returns the output. Here are some advantages of C++ recursion. First one, it makes our code shorter and clear and cleaner. Second one, recursion is required in problems concerning data structures and advanced algorithms such as graph and tree traversals. It also have some disadvantage. So disadvantage of C++ recursion is number one, it takes a lot of stack space compared to an iterative program. Number two, it uses more process time. Number three, it can be more difficult to debug compared to an equivalent iterative program. So in the last of this chapter, we see some C++ standard library header files. These are the C++ standard library is divided into many portions, each with its own header. List some common C++ standard libraries as IOStream, CMath, cstd.lib. So a type of function that is available as a part of language is known as built-in function or library functions. These functions are ready-made programs. These functions are stored in different header files. Built-in functions make programming faster and easier. C++ language provides many built-in functions to solve different problems. Different built-in functions are defined in different header files. Built-in functions can be accessed in programs by including the header files in which these functions are defined. Some of these standard header files or standard libraries are iostream, cmaths, cstd. The word conio stands for console input output. The header file conio.h contains the built-in functions that are used for input and output. Some important functions defined in this header file are as follows. CLR SCR clear screen. The word CLR SCR stand for clear screen. The function is used to clear the contents of the screen. When this function is executed, the screen is cleared and the cursor moves to the start of the first line on the screen. CLREOL. The word CLREOL stands for clear end of line. The function is used to clear current line from current cursor position to the end of line. The remaining text on screen is not cleared. Similarly, get.ch. The word get stands for get character. The function is used to input single character from the keyboard. The character type by the user does not appear on the screen. It can be stored in a variable by using assignment statement. The user does not need to press enter key to complete the input. The function is frequently used to pause program execution. Get.che. The word get.che stands for get character echo. The function is used to input single character from the keyboard. The character type by the user also appear on the screen. It can be stored in a variable by using assignment statement. The user does not need to press enter key to complete the input. KB hit. The function KB hit stands for keyboard hit. The function is used to check if the user hit the keyboard or not. It returns a non-zero value if the user hits any key on the keyboard and returns 0 otherwise. The value of the key can also be stored in a variable by using assignment statement. Go to XY. The go to XY function is used to move the cursor to a specific location on the screen. It moves the cursor with respect to x-axis and y-axis. It is very useful when the output is to be displayed by a specific location on the screen. Text color. The function is used to change the text color. Studio.h header file. The word studio stands for standard input output. The studio.h header file contains different functions that are used in the task of input and output. Some important functions defined in this header file are as followed. Get.char. The word get.char stands for get character. The function works similar to get.ch and get.che functions of conio.h header file. It is used to input single character from keyboard. The character can be stored in a variable by using assignment statement. The user needs to press enter key to complete input. The character typed by the user also appears on the screen. Put char. The word put char stands for put character. The function is used to display single character on the screen. Gets. The word gets stands for get string. Gets string. The function is used to input a string value from keyboard. The value entered by the user can be stored in an array of characters. The string may consist of any characters and space. The user also need to press enter key after typing the string to complete the input. A null character is added at the end of string automatically when the user press enter key. Put s. The word put s stands for put string. The function is used to display a string value on the screen. It can display both string values as well as string constant. The string constant is enclosed in double quotation marks. Math function math.h. The header file math.h contains the built-in functions that are used to perform arithmetic calculations. Some important functions defined in this header file are as follows. ABS. The ABS function is used to find the absolute value of an integer. FABS. The FABS function is used to find the absolute value of a floating point number. CEIL. The CEIL function rounds a float or double value to the next integer and returns it. Floor. The floor function rounds a float or double value to an integer and returns it. The rounded value is not greater than the original value. Cos. The cos function is used to find the trigonometric cosine of specific angle. The angle is given in radians as floating point value. Sine. The sine function is used to find the trigonometric sine of specific angle. The angle is given in radians as floating point value. Tan. The tan function is used to find the trigonometric tangent of the specific angle. The angle is given in radians as floating point value. Log. The log function is used to find the natural logarithm of a given floating point value. Log 10. The log 10 function is used to find base 10 logarithm to find floating point value. Fmode. The fmode function is used to find remainder by dividing two floating point values. Similarly, to find the power of one integer raised to the power of second integer, we use function POW, and to find the square root of a given number we use square root. The square root function is used to calculate the square root of a floating point number. cctype.h. The cctype.h header file declares a set of functions to classify and transform individual characters. For example, is upper check whether a character is uppercase or not. Similarly, to ASCII, the toASCII function is used to convert a character to an ASCII character if the character is already a valid character. It is returned unchanged. ToLower. The ToLower function is used to convert a character to lowercase character if the character is already in lower case. So that's all for today's lecture. And always remember that programming is a skill best acquired by practice and example rather than from books or taking lectures. So try to program again and again to get the best knowledge of C++ language. Thank you